All right. Let's try this again. So we've already looked at visually how we kind of display data. I wanted to go through and show you how we do some of this in Excel. Okay. So the very first thing that we're going to work on is this tuition chapter 2 example blank file. I'll have the completed version up on Canvas as well with all the work that we do, but this is going to be the video that kind of shows you how all that work was put in there. So we're going to start out with an easy one first, which is a time series graph. So you might think initially we can just kind of highlight the year and the different unemployment rates for the US. You go to insert. We've got these different chart options over here. We just want a line graph. The problem is if we do it this way, it tries to graph those years as well as the unemployment rate. And so this really isn't what we want. Right? So I'm going to delete this. So what you actually want, if we select kind of the US unemployment rate, right, we go to insert a line graph here. It kind of puts that title as our chart title now. I think maybe in the slides, I changed the chart title a little bit, but this is the exact same thing that we had in slides. Now, one thing that isn't the same is I just have numbers here. I want the actual years to be there. So I'm going to click on those numbers. If I right click on a PC, hold control and just click, left click on a Mac, and then I'm going to select data. There's this horizontal axis labels options. I'm then going to select those years. And then going to hit OK. Now I've got this nice time series graph where I can follow what the US unemployment rate was doing over this time period. Now, what if I wanted to add Canada in there as well? Right? So this was the one that I showed you in the slides. Here's going to be one that's a little bit different. If I select both the US and Canada, I then go to create this line graph. What it'll do is it's going to create a time series for the US and a time series for the Canada. If I had multiple other columns, other countries, it would be putting more and more lines in the same graph, and then giving me this kind of legend here that lets me know this orange line is unemployment in Canada, blue line unemployment in the US. Both were kind of similarly impacted by COVID. Canada wasn't hit as hard by that economic recession that the US had. We also then could go back in, once again, right click or control click on a Mac, select data. I'm going to select these years. So we get those put in there. Oh, what did I do? What did I do? Here, we'll try this again. I think I accidentally had my cursor up here when I clicked it. So go to my axis labels, select these, then go back, hit OK. There we go. Now I have the US and Canada all in the same graph, and I could play around with the chart title if I get real fancy, right? So it's pretty easy. Another type of graph we talked about was a scatter plot. So the data here is a little bit smaller. So we'll, once again, zoom in here so we can kind of see. So this is the percent vaccinated of every state. And then this is the cases they had per COVID cases they had per 100,000 people. So I'm going to select these two columns. So kind of a shortcut in Excel to like make things easier, instead of like dragging all the way down. If I hold Control and Shift and I hit the over arrow, it'll go all the way over in either direction to wherever the data stops. So here, I'm going to hold Shift and Control, or on a Mac, Shift and Command. If I ever forget when I say things, on a PC, generally it's Control. And if I forget to say it on a Mac, it replaces Control with Command. So then I hit the over arrow, hit the down arrow. It's now selected every single state. Now I'm going to go back up to insert. Here's my chart types. Oh, I've got this nice scatter plot. Here I've got my scatter plot, right? And I can add in axis labels stuff. I'm not going to get real finicky about that. The goal of this class is for me is to teach you how to put this data into a visual representation. In terms of making graphs look nice, that's a different class, right? You're kind of playing around with the intricacies of Excel's like formatting stuff. So I won't waste a lot of time with that. But here's our scatter plot. And once again, we kind of see, okay, as you get higher percent vaccinated, tends to be that the cases are kind of going down, it looks like. So those ones are pretty easy. We're selecting the data, inserting the type of graph we want, whether it's a time series or a scatter plot. What I'm then going to go through and do is show you how we do a frequency distribution for qualitative and then quantitative variables. So once again, we'll zoom in so we can actually see what we're doing here. And I've got like a small 20-person class and different letter grades given to different people. I also have their numerical grade. But let's first kind of look at how I would do this with qualitative data. So when I want to count the frequency, instead of going through and doing this by hand, so okay, there's 1, 2, 3, 3 A's. If I had a much larger data set, like the one I mentioned in the previous video, like hundreds of students, I don't want to go through and do that by hand. I can have this built-in function in Excel do it for me. So anytime I want to use Excel to do math or a built-in function, I start with the equal sign. I then say, okay, I want to count this if something is true. So we're going to use this count if, and then put a parentheses. I'm going to say, okay, go through this range of data. So what's the range of data? Here's all of my letter grades. Now I want to count this, comma, if a certain criteria is true. Now notice I'm typing in all those things in the cell. You can go up here to the formula bar and it kind of reminds you, okay, yeah, this count if built-in function needs two things, the range, but then also what's your criteria. So we want to count it only if it is equal to, and we have to put that in parentheses. It's just the syntax of Excel. I'm then going to show you, you could just do the letter A, right? And I believe if I do this, it's not going to like it, okay? Well, why? I think I actually need to use this and sign and put in parentheses A. Now it counts that, right? So these parentheses kind of let it know, oh, you're counting something and we're looking at text data, right? Qualitative data. Now this and sign is just something we're going to start using, getting good practice using. Once again, just the syntax of Excel. So go through their data, count it if it's equal to what? Equal to this value of A. Now, what I could also do is if instead of putting A in there, because, okay, I'll go back. So I could do that, and then I have to, for B, okay, I gotta count if and count it, type it all in again. Instead, if I didn't put the value and I use this cell reference, I click on the cell where that where the letter A is. Well, now when I copy this down, D3 will become D4. So then the next one would count it if it's equal to B. Then the next one would count it if it's equal to C, so on and so forth. So if we notice here, I could do that. Okay, it looks like everything's working right? So, oh yeah, 1F, looks like there's 8 Bs. There's only one problem. If I count the Bs, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, why am I missing some? Because when I copied this down, not only did my cell reference for what I wanted to count it, my criteria was updating, but so was my range of data. So notice here, it's missing the first observation. So what's one thing we talked about in the last video, even kind of alluded to it, or show you how to do this. I need to, what we say, freeze this cell reference. So I could go and manually put the dollar signs in front of each row and each column reference, and that should work. Or we said the shortcut is I can highlight what I want to freeze on a Mac, Command T, on a like PC, it's usually F4, or you have to hold your FN or function key in F4. Now, and also just once again, I start out assuming you don't know anything about Excel, but when I'm in this cell, easy way to get out, notice if I try to start using my arrow keys to get out of it, well, now I'm locked in. But it'll start putting in different cell references. So like, let's say I want to get out and I start to hit over and I'll now jimmy it out. But an easy way to get out of this cell is just to hit enter, right? Or return. So then I'm going to copy this down. Now, oh yeah, now I'm picking up all of the B's because it's still using the correct range of data. So that's how you would build a frequency distribution with qualitative data. I'll now show you how we would do it when we have like quantitative or continuous data, and how we would then take and extend these frequencies to be like relative frequencies or percent frequencies. Now, one thing we also had talked about, I highlight this here, whoops, is kind of doing like a percent frequency, right? So how could I come up with this? Well, we were going to say we take the frequency, divided by the total number of observations, and then multiply by 100. Well, I don't know what the total number of observations are, but one function that we have in Excel is this sum function. So if we use this sum function, whatever range we highlight, it will then go through and add up all of those values. So once again, I'll hit enter to get out of that cell. It looks like I had 20 observations. So I'm going to take the frequency for category 1. I'm going to divide that by the total number of observations. I'm then going to take that. I don't need the parentheses here, but just to kind of make it look a little nicer, I'm then going to multiply it by 100. Now, when I copy this down, we want E3 to update to, oh yeah, here I want to calculate the percent frequency for bees. So I want it to become E4, but I want this cell reference of E8 to always be the same. So once again, we'll highlight this, Command T on a Mac, F4 or FNF4 on a PC, hit enter to get out of the cell, copy this down. Now I've got my percent frequencies. If I add those percent frequencies up, if I haven't made any mistakes, hopefully this should add up to, well, it's every single possible letter grade I could see. Well, I didn't have any incompletes or withdrawals or anything. So they should add up to 100%. Sure enough, they do. So that's a good kind of check to make sure like I've done everything correctly when I created those percent frequencies. I could then take those percent frequencies, do my little pie graph. Once again, oh, I don't want 1, 2, 3, 4. What I want those x-axis labels to be. Now I've got, okay, here's my A's, here's my B's, C's, D's, and F's. Right? So nice, quick, easy way we can create a pie graph there of our percent frequencies. Now it gets a little bit trickier. We'll go over to this other worksheet, which is tuition. So I can't remember if I failed to mention at the beginning, but when we're working in an Excel file, just some terminology, it's generally called a workbook, but each workbook can contain multiple worksheets. So we just had different data on each worksheet. Here I've got one where I've got a bunch of different universities. Right? We can probably find IU if we scroll down. I've got their out-of-state, their in-state, total tuition or in-state tuition. I think this was the number of kind of total like room and board plus the in-state tuition. So here I'm just going to be concerned with just in-state tuition. Right? We could compare any of these other variables, but here I'm just going to look at that in-state tuition. Okay. So first thing I'm going to do is like, hey, look, how many bins do I want? Well, I'm going to tell you that you want 8. You don't always have to, this is kind of up to subjective. If you're creating a histogram, you can choose as many as you want. So the first thing that we'll do is say, okay, look, I'm going to find the minimum, right? We need the minimum and the maximum and the number of bins to calculate the optimal bin length. So I'm going to find the minimum here, right? What am I going to do? The minimum of this column G or in-state tuition. So I'm going to then, instead of, highlighting all the way down, because there are lots of observations here, a nice easy shortcut is once I select the first observation, hold control shift or command shift on a Mac, hit your down arrow, okay? Then hit enter, and it's going to give you that minimum value in that range, right? That minimum value of that variable in-state tuition. We then are going to look at a built-in function, which is max, which finds the maximum. So now I'm going to select once again, first observation, control shift, command shift on the Mac, hit the down arrow. Now, if I try to scroll up, like I can do that and, get out of the cell. But if I just hit enter, it automatically returns me back up to that. Okay. Now I'm already thinking though, I think the one that I showed you in class, just so we get this to line up, my guess is I showed you out of state. So let's instead, this is a nice way too, I've got everything selected correctly, but I think to make the line up with what we did in the slides, let's do, whoa. How is the minimum 1430? What was it before? Oh, yeah, I guess it is. I guess there's schools where people are basically going for free. So, oh, I didn't want to do that. Anytime you want to undo, right, you can kind of undo. So we'll go up here. I'll just click on the formula bar, change this to the out-of-state tuition variable. I can type. There we go. That's the one I use for class. So we've got 8 bins here. What's my optimal bin length? Well, that'll just simply be the difference between my maximum and my minimum tuition here in the data set, and divide that by the total number of bins. Okay. And I'm going to hit enter. I've got about what, 9,200 is my bin length. So this is where in class it's okay, look, you could kind of do it this way where you say, okay, I'm going to set up, it's a nice easy way, the minimum and maximum of each bin. So the first bin is going to start at 0. The next bin, or it's starting, and it's going to end at that minimum value plus whatever that optimal bin length is. Okay. The next one, I could say, okay, look, well, it's going to start where the last one left off. So I can do that. And then once again, the maximum will just be this bin plus whatever the bin length is. Right, wherever the bin starts, sorry, plus the bin length. I then kind of keep doing that, but notice if I copy this down, it's always going to become, instead of N7, the next one will be, oh, N8. And this will always take this plus my optimal bin length. Now I want this to update when I copy it down to be not M8, but M9. However, I don't want this cell reference to change. So Command T or F4 on PC. Okay. Now I can drag this down. Notice, what did I do wrong here? 9165. Oh, that's fine. I see what I did. So technically I shouldn't have started this at 0 because I know the minimum. I really should have been starting this at the minimum. That way now it gets up to, okay, my maximum value. Right? Now in practice, like these numbers, if I'm going to start putting these in a graph, it starts to look pretty, it's a lot going on. So instead of this optimal bin length, usually use this like, this is a good place to start, right? So I want to make sure that if I then, okay, I'm going to round this to be like a nice easy number to look at. I wouldn't want to choose 9,000 because if I choose a number that's smaller than that optimal bin length, notice when we get to the very last bin, its maximum point is going to be less than the maximum value in the data set. So we wouldn't be counting any observation that's above this. However, if we round it up, it's like a nice, easy to look at number like 10,000. And I start it instead at 0. Well, now I get something that it's going to still count every single observation, right? The last bin has a maximum greater than the maximum value in the data set. And these just look a lot nicer, right? $10,000 jump categories. Okay. Now from here, what we want is our frequency. So I've got the maximum minimum of each one of these. Now I'm going to include, I think one more thing here, just to make this easier. This will take a little bit of time. But what do I want? I want to call these my labels, right? So this is going to be 0, greater than 0. Here's our random variable X, right? For representing kind of tuition. And then not less than, I'm actually going to put in a symbol here, which is I want a less than or equal to sign. Now I forget where it's at. I do know. Should be. Oh, right here. Less than or equal to. There we go. So I'm going to put that in there. All right. Get rid of this. So up to 10,000. And I could go through, actually, easier way than finding that simple every single time. Oops. I'm just going to copy this for all of these. And I'm going to change the numbers anyways. So this one will be 10,000 to 20,000. You know, this takes a little bit of time, but you'll see when we get to the end, it gives it so I have kind of a nice looking graph, some nice labels to look at on the x-axis. Otherwise, you know, I could put just the bin numbers, and that's fine, especially if I have kind of somewhere else what those bin numbers, where their minimum maximum values are. But like I said, I just want this to look a little bit prettier, and I've got a little bit of time here to not make this video too long. So I'm just going to go through, create these. Almost done. So once I have these labels created, when I added an extra 0, I'm going to have to use the COUNTIF function again, just like I did for the qualitative data. It's just that now I'm going to have to count it if it's not equal to A, but if it's greater than 0 or less than or equal to 10,000. So instead of the COUNTIF formula, oh, this makes sense. There's a COUNTIFs formula where you can check to see if multiple things are true. If the value is above 0, but also is it less than or equal to 100,000? Or sorry, 110,000. Hopefully no one's paying 100,000 in tuition, right? Well, I guess collectively you kind of are. So COUNTIFs, we're then going to go to this out of state variable. I'm then going to once again Control Shift, select it here. And this is where I could scroll all the way up. I could keep typing here in my formula bar. I'm going to scroll up so you can see it easier. But in practice, it's a bit easier for you to then start to kind of, okay, comma, I want to look through this data and count it if this next criteria is true. You can type it all in the formula bar. I'm just going to scroll up here, which takes a little bit of time, but just so that we can see it a little bit better. I'm going to zoom in after this so we can see it even better. So the first thing I want to do is say, I want to count this data if it's greater than the value of 0. So instead of using the numbers, I'm going to actually use this cell reference. Because for the next category, I'm going to want to count it if it's greater than 10,000 and 20 and 30. So I can kind of imagine as I copy this formula down, this cell reference is going to update the way I want it to. Now, one thing that's kind of goofy here, and we'll see why in later chapters, why this COUNTIFs formula is formatted the way it is here, but I can't just do comma and tell it the second criteria. I have to retell it, okay, check to see if this variable is greater than 0, but also check to see if this variable is less than or equal to 10,000. Now, basically because later on we can use this COUNTIFs to check one condition about one variable and one about another. But for this one, we want two conditions, but we're looking at the same variable. So I would select this entire range of data again. Instead of doing that and having to scroll all the way back up, I can see what that range of data is. I already selected it once. It's J2, and then we put a kind of colon here that says go all the way through J1853 or 1,853. And then put another comma. So I tell it the data, range of data, first criteria. Tell it the range of data again and say, okay, I only want to count it if it's less than or equal to. So this is where I don't have to worry about hunting to find to insert that symbol. I just type it in the way we would say it, less than or equal to. Now, similar to when I was looking at, is it equal to or less than, I have to put that in quotation marks. I'm going to say, is it less than or equal to the maximum of my bin? Okay. So scroll over here so we can get this all in one line. So this is great, right? I'm going to put a parentheses, hit enter to get out of the cell. Looks like there were 78 of these universities, right, that had tuition between 0 and 10,000. Now, if I want to copy this down, right, I want these references to, instead of be 0 and 10, to become 10 and 20, or instead of M7 and 7, be M8 and 8. So that'll be good when I copy it down. But the range of data, I always want to stay the same. So I'm going to Command T or hit F4, highlight it, and hit F4 on a PC. Command T was a Mac. And now I froze those cell references. Hit enter to get out of the cell. Now when I copy this down, oops, I can get this to show it to you. There you go. Still selecting the same range of data, but it's updated the minimum maximum to be the minimum maximum for whatever bin I'm looking at. Okay. All right. Excuse me. So one thing I could think about is if I add all of these frequencies up, if I've set my bins up correctly, so they're completely exhaustive, that they're mutually exclusive, I should have it that they add up to the total number of observations. So I can use that sum function to see, okay, when I added these up, I counted 1,852 observations. How can I check this? So a nice way to check this is initially, if you use a just count function, it just counts how many cells have a variable, or sorry, have a value in them. So I'm going to select, once again, Control Shift or Command Shift on a Mac, hit the down arrow, then hit Enter. Sure enough, it just counts the number of observations, and it's exactly what I got up here. If I had done something like try to choose 9,000, right, as my bin length, oh yeah, I'm missing a few, right? And that's because the maximum of the last bin wasn't quite as high as the maximum of the data set. But when I round it up to kind of make this nice, easy to look at bin length, there I'm making sure I count every single observation once and only once. Okay. The next thing we're going to create is our relative frequency. We don't have to do this every single time. Maybe I want to jump right to the percent frequency, but I'm going to kind of break this down step by step. So here's my relative frequency. All I'm going to do is take the frequency for this bin divided by total number of observations. When I copy this down, I want to use the next bin's frequency, but I always want to use the total number of observations. So I'm going to put $signs in front of my row and column reference. Now I'm going to copy this down. Hopefully, if I use that sum function and add up these relative frequencies, what should these always add up to? Well, we said that should always add up to 1 if I've done things correctly. Okay. What if I wanted my percent frequencies? Let's just take this cell, multiply by 100. Right? Similar to the other one, I could put this in a pie chart now. Right? I could also graph this, right? Use my frequencies, go to Insert. Here's my bar graph. Now I've got my nice histogram. Hold control or click and hold control, or sorry, hold control and then click if you're on a Mac, right click if you're on a PC, go to select data. We'll just change those axis labels to be these nice labels we created. So instead of just these bin numbers, we actually can kind of see what these bins, what tuition values they correspond to. And I could change the chart title and play around with that. Okay. I could also do the same thing with the relative frequencies. If I do that, I should find the exact same graph. So notice I put these side by side and I try to make them the same. It's the same, well, except for you can't see. There you go. It's the same shape. I just haven't added the axis labels. And instead of telling me the frequencies of each one of these bins, I have the relative frequencies. Okay. Now, one other thing I briefly talked about, and I think it's probably going to make more sense as you see this in practice, is we could come up with what we call a cumulative relative frequency graph. And I could do this with the percentages. For the sake of this example, to get it to line up with more what's in the book and also what I talked about in the slides, we're going to look at a cumulative relative frequency. So all a cumulative relative frequency is it's going to be the relative frequency of the bin you're looking at and every bin before it. Well, for this very first bin, there's no other bins before it, so the cumulative relative frequency for that first bin is always just the same as that bin's relative frequency. Now for the second one, it would be the sum of that bin's frequency and every bin below it. And the next one would be the frequency of this bin and every bin below it. Or we can kind of think about it almost like what this is saying is, this is if it's in between, I'm going to shorthand this just to make it easy. 0 to 10,000, 0 to 20,000. the portion of the data between 0 and 30,000, so on and so forth. That's what my cumulative relative frequency would kind of be. Right? So is it the observation in this bin or any bin below it? Now, if I keep doing this, what I should get to at the very end, when I looked at this cumulative frequency for the last bin, cumulative relative frequency, that would be its relative frequency plus every bin below it. It should be 1, right? That should be all of the data. Now, an easier way to do this, instead of typing this sum function over and over, it's always going to be that the cumulative relative frequency is the frequency of the bin you're looking at plus the cumulative relative frequency from the bin right before the one you looked at, right? So notice here, hopefully if I move this down, I should get 0.36. Sure enough, I did, right? It's just taking the relative frequency of this bin plus the cumulative relative frequency from the bin before it. If I drag this all the way down, hopefully I still get 1 here for my last bin. I could then take those cumulative frequencies. I think the graph I showed you in the slides, it's just a line graph. So I'm going to insert this line graph. Here's my cumulative relative frequency. I could change the axes to be these labels. But that's how I'm going to create that cumulative relative frequency. Once again, hold Control, click, or right click on a PC. And just add these axis labels. Here's like my different bins. Okay, all right, I can kind of play with the chart title, but here's my cumulative relative frequency. Here's my 2 kind of histograms, right? One showing the frequency, one showing the relative frequency. And that's kind of just a way we would build those out, right? Now, there is a built-in tool that you can use in Excel. I have you doing it this way for a reason, because we're going to use these formulas, the sum function, the count ifs. We're going to use this all throughout the semester. So I want you to have a good understanding and mastery of these moving forward. But to be completely honest, there is a built-in tool that we don't have to go through as much work usually. Okay. So if I select this out-of-state tuition variable and then go to insert, looks like there's like a distribution graph, like a histogram already here. Oh, there's a histogram option. Notice it'll build this for me, although it's going to put it all the way at the bottom of the data. So that's kind of annoying. But if I put it up here, just so we can have kind of a comparison, notice it kind of chooses the number of bins. So it's going to look a little bit different, but we still get the kind of same distributional shape, right? If we go to format chart area, I think this is what I want. Except for where did it go? Oh, my computer is being slow. There we go. It's slide data. So, oh, I forget. There's ways you can play around with. There's like all these options. You can go, oh, here it is. Select data, change chart type, add chart element. You can play around with it. I forget because I never do it this way. But you can play around with like, so you can choose different values. Here, it just kind of defaulted and it did what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different bins. It then kind of created the optimal bin length based off of that, calculated those. If you ever, these aren't like nice numbers to look at. So doing it by hand allows you to kind of create what seems like more reasonable bins, like $10,000 jumps, as opposed to what I don't even know, these are 5,000 or something. Not even 5,000, right? 4,600. So, you can do it this way, and it gives you a nice quick snapshot of the distribution of the data looks like. If we're trying to compare this to things that we talked about, it looks like tuition is actually fairly normally distributed. Maybe a little bit of a right skew, that right tail might be a little bit longer, but pretty close to a nice normal distribution. So this is how you would build relative frequency, percent frequency, or calculate relative percent frequencies and frequencies of different bins, create histograms, create cumulative frequency polygons, all things that I showed you examples of. We also looked at scatter plots. Here it is. We looked at time series. We also looked at creating these histograms for qualitative variables as well. So I'll have all of this work. In fact, save this file. So you'll have all the work I did in the video to kind of go back and look at. And this will be what your first Excel assignment has some additional stuff as well, but this will be a main component where you're going to have to build a histogram calculating these relative frequencies, percent frequencies, maybe making a cumulative frequency polygon for a different data set. Okay.